So today we're looking at a linear equation versus an exponential equation. We'll often use the word model to kind of explain that. So linear is what we've been working on a lot this year, y equals mx plus b. And just a reminder that m is our slope and b is the y-intercept. And then just to kind of look a little bit at the linear, we have 0, 1, 2, 3, 4. We can choose those x's if there isn't any in there. And what this is telling us is that we are going to replace this x in the equation with the x value I have here. So that would be 3 times 0 plus 2, or 0 plus 2, which equals 2. And then I would do that the same. The only thing I'm changing is what's in the parentheses. So 3 plus 2, which is 5. 3 times 2 plus 2, or 6 plus 2, which is 8. 3 times 3 plus 2, which is 9 plus 2, to be 11, or 3 times 4 plus 2. So 12 plus 2 is 14. One way that I can definitely tell that this is linear is that if I'm looking, the change each time ends up being a plus 3. And if I don't see that, I can take the second number minus the first, so like 5 minus 2, 8 minus 5. If I think it's linear, I'm going to subtract, and they would have to always be adding the exact same amount every single time. And then when we look at the graph on that, that graph is going to be a straight line. So if I just graph those data points, I just graph whatever I had in the table, I can clearly see it's a straight line. So that's linear. That's all stuff that we've been doing. Looking at exponential, exponential is slightly different. Our equation is y equals a, and then in parentheses, b to the power of x. Notice that x is that exponent. It's smaller. It's raised. A stands for the y-intercept, or the initial value. I don't get to choose the letters, or I wouldn't make it kind of confusing to have a b in here and a b in the other equation. I-N-I-T-I-E-L value. And b is our growth or decay factor. So depending on if we're getting bigger or smaller, it's not a slope. Slope definitely always is referring to a linear line, and that's not what we have here. Same thing with our 0, 1, 2, 3, 4. And then we are replacing, in this case, that exponent each time. So I'm just writing out what I'm doing each time. So everywhere there's an x still is what I'm replacing. And we just did a whole bunch of things on exponents. So remember, if we are plugging those in, we haven't really done 3 to the 0 power. We're going to kind of look at it right now. Oops, we get an ad. But 3 to the 0 power is just going to end up equaling 1. Not seeing where I can close this out. Let's just get rid of it. So we end up with 2 times 1. You can type it into the calculator, and you can see where that is. And if you think about it, it's kind of telling me right when I start. So right when I start, it should be my y-intercept, or my initial value. And then 3 to the first is just 3, so 2 times 3, which is going to end up being 6. 3 squared is 9, so 2 times 9 is 18. 3 to the third is 27. So when I double that, I get 54. And then 3 to the fourth, I'm going to just use my calculator off to the side. I get 81. So 2 times 81, 164. So one thing I can tell is I'm clearly not just adding or subtracting each time. I'm getting a much bigger jump than that. So remember, this is where I can take 6 divided by 2, and that equals 3. Or 18 divided by 6. So each time I am multiplying by 3. Graphing that data, I can definitely see where that curve is. It is clearly not a straight line. When we're looking at these, I'm only going to give you the option of linear or exponential. I'm not going to throw in another. That would just be confusing. We're not going to worry about domain and range at this point. You will be looking at that more next year. So when I give you a variety of tables, what you're going to end up doing, if I look at the middle table here, you're going to look and determine, is this exponential or is it linear? So the first thing I'm going to do is I'm going to look to see, how do I get between these two numbers? And I generally look to see if it's linear. And if it's linear, I subtract 3. And then I see if I can do it again. And since I can subtract 3 both or everywhere I go, that tells me it's linear. Remember that whatever it is that we're doing on the side for a linear equation, that's my slope. And my y-intercept happens when x is 0. So I know it's linear. So y equals mx times mx plus b. So y equals negative 3x plus 20. if we look at this last one, I can tell that when I do 81 minus 27, it's not going to be the same I'm not going to be subtracting the same amount every time, especially because from 81 to 27 is a much bigger jump than from 3 to 1. So that's telling me it has to be an exponential. I know it's a decay because I'm going down. Either way, I'm still going to find that exponential the same way. 27 divided by 81, it equals a third, or 0.3 repeating. 9 divided by 27, I usually like to do it at least twice just to make sure. So exponential. And it's y equals a, so 81 times 1/3 to the power of x. If you wanted to use the repeating, make sure you're putting that little bar over the top, or if you're typing it into the calculator, you're typing in a whole bunch of 3s. So then we just have some more tables, same thing. Answer key is on that Canvas page, so please make sure you're looking at that. I see I did not erase far enough down here with our stories, so we'll just kind of quickly erase those. So what you're going to end up doing is just looking at a story and seeing if it's linear or exponential. And then writing an equation. A library has 8,000 books and is adding 500 books more each year. This adding is telling you that happens in a linear. Adding, subtracting, sometimes I use plus. So that's going to be linear. And if you think about it, it says I have 8,000 books, then I have 8,500, then I have 9,000, which is definitely a linear. It's 500 added each time, plus my initial amount of 8,000. If you chose to write this as 8,000 first, plus 500x, that would still work. A gym customer must pay $50 for a membership plus $3 each time they use the gym. That's my linear. It's going to be 50 plus 3x, or again, 3x plus 50. A bank account starts with $10. Every month the amount in the account is tripled. That tripled means times 3. So that's going to be exponential. I'm starting with 10, 3 to the power of x. The last one, there's 20,000 owls in the wild. Every decade, the number of owls is halved. Same idea. To be halved, I'm going to multiply by 0.5. So I'm just taking 1/2 and putting it as a decimal. Starting with 20,000 times 0.5 to the power of x. The tables on the bottom are similar to what we did before. The answer keys on Canvas, so feel free to check it.